Hello everyone, I'm Sir Isidro San Pedro. I'm here to present the DBMS or the Database Management System that I've worked on. Now I'll present my FMA1 and FMA2 outputs. For FMA1, first task is to select one activity or task around our workplace, home, or school which could be done faster or more efficiently with the help of a DBMS. I chose to create a DBMS in which it collates in a database the class list of MMS 144 with respect to their sections and groups. I chose to create this simple database to help distinguish which sections or groups the students are part of or belong to. For task 2, I created the conceptual database design with 4 tables: student table, group table, section table, and subject table. For the first table, the student entity, the attributes are student number, first name, last name, and program. Student number is the primary key, and all of them are type strings. Next is the group table, entity group with attributes group number, topic, and submission date. The attribute group number is the primary key with type numeric because there are 4 groups, so they are numbered as 1 to 4. The topic is a type string. Submission date is a type date, which is numerical classification of date, month, day, and year. Next is the section table. This is the section is the entity, and the attributes are section letter and platform. Section letter is A and B. Letter A, section A is for the My Portal platform, and section B is for the Facebook page platform. Section letter is a primary key. Both of them are type strings. So we go to subject table. Subject is the entity with attributes subject name, term, and school year, and teacher. Subject name is the subject name is the primary key, and all of them are type strings. Conceptual database design. Now, for the conceptual database design, the tables are arranged as so. The subject table, the student table, the section table, and the group table. Okay. Now, this is the entity. And these are the attributes. For the relationship between the subject table and the student table is 1:many. So only one subject, that is the MMS 144 subject, and to many students, the students enrolled in the subject, the relationship between the subject table and the section table is also 1:many. The MMS subject and to the many section, the two sections A and B, the My Portal section and the Facebook section. Next is the relationship between the section table and the group section is a many-to-many relationship, meaning many sections, the two sections A and B, and to many groups 1 and 1 to 4. Now for the physical database design, this is the structure of the tables with entities and attributes aligned horizontally. I have written sample records and fields for each table. For the student table, there are sample student numbers of the students, and sample name, first names, sample last names, and sample degree programs. For the group table, there are 4 groups in each section, so the group number is numbered from 1 to 4, and the topics are the real topics for each group. And this is what I'm talking about: the submission date, type numerical, the month, the day, and the year. For the subject table, first for the section table, section letter A and B. Platform for section A is my portal. Platform for section B is Facebook page. For the subject table, the foreign key student number are put at the first row, and the group number put at the second row, and the foreign key section letter at the last row. They are aligned. Which student is in the group in section, which student is in group A or group B. Task 3. Now for task 3, the difference on how my database would look like using the different data models: hierarchical, network, and relational. For the hierarchical model, using a tree structure diagram, this will my database look like. The tables are defined with entity and attributes. Entity attributes. At the top of the hierarchical model is the subject table, and below it is the section table, group table, and student table. For the network model, this will be the look of my database. The subject table will connect to the section and group, and the section has 4 groups. Each section A has 4 groups, and section B has 4 groups. And then the group table is connected to the student table. Each group has their specific students to which and they will report on their specific topics. Now for the model, now for the relational model, this will be the look of my database. The same with the conceptual database design. Now for task 4, which is the most appropriate data model to use for my database? I think among the 6 data models, the hierarchical model is the most appropriate to use for my type of database, for the reason that my database includes entities that are structured from a large group of quantity to smaller quantities. A hierarchical model simplifies data overview over my database and allows for much better understanding of what my database wishes to convey. An advantage of using hierarchical model for my database is that it easily shows that distribution of entities part by part from biggest to smallest, from top to bottom. Now for the FMA2, which among the basic DMMS functions would you apply for your database? I would apply the add student function, the delete student function, edit student function, and the search student name function. First is for the add student function. What this function does is that it adds a certain student belonging to the class. This function is used in the database to put additional entry of a student to be stored in the database record. This function is executed by just adding and adding entries to the database with the use of the DBMS function add_student. Next function is the delete student function. What this function does is that it removes a certain student from the database. If I would like to omit or delete a particular student from the database, I would use this function. I would just use this function delete student to strike out a name of a student from the database. Next is the edit student. This function allows for an edit or change to take place within the database. This function particularly modifies the content of the student's record, example, class number, spelling of student's name, etc. This function is needed for my database so that I can correct the errors I've made in inputting the contents. Next is the search student name function. Above the delete and the edit functions is the search function. Before I can delete and edit a certain student, I must find it first, right? So the search student name function allows me to browse or find a particular student that I want to view. This function also allows me to find out if this certain student is part of this certain group. In the case of my database, the My Portal group or the Facebook page group. It also allows me to know if a specific student exists in my database or in the class person. Next task is to identify the system failures that can possibly happen to my database and discuss my recovery plans. These are the possible system failures. First is the user error failure. Second is the statement failure. Third is the process failure. Fourth is the network failure. And lastly, I added another failure. It is the database instance failure. Let me define each type of failure. First is the user error failure. It is an example. An example of this is accidentally dropping a table. There can be few ways to prevent user errors, but it can be reduced by learning more and expanding the knowledge in database and application principles. Furthermore, by planning an effective recovery scheme ahead of time, The work necessary to recover from user errors will be lessened. Next is the statement failure. Occurs when there is a logical failure in the handling of a statement in the language program. A recovery plan for statement failures is to roll back the effects of the statement and return control to the application. Re-execute the statement after correcting the problem indicated by the error message. Next is the process failure. It is a failure in the user, server, or background process, such as an abnormal disconnect or process termination. Recovery plan includes detecting the aborted process. If the aborted process is a user or server process, resolve the failure by rolling back the current transaction of the aborted process and release any resources that this process is using. Recovery of the failed user or server process is automatic. If the aborted process is a background process, the instance usually cannot continue to function correctly. Therefore, you must shut down and restart the instance. Next is the network failure, such as aborted phone connections or network communication software failures. The recovery plan is, after the network problem is corrected, detect and resolve the aborted server process for the disconnected user process. Next is the additional failure of database instance failure. This occurs when a problem arises that prevents a database instance from continuing to work. An instance failure can result from a hardware problem, such as a power outage, or a software problem, such as an operating system crash. Instance failure also results when you issue a shutdown abort or a startup force statement. Recovery. Crash or instance recovery recovers a database to its transaction consistent state just before instance failure. Crash recovery recovers a database in a single instance configuration, and instance recovery recovers a database. Now for task 3, identify the media failures that can possibly happen to my database and discuss my recovery plans. A. Read and write failure means that there is a physical problem reading or writing files on the storage medium. Next is the disk head crash. This failure causes the loss of all files on a disk drive. Recovery plan. There can be so little that can be done to recover from this error. The crash or instance recovery usually can be performed, in which case the instance can be restarted. However, if a data file is permanently damaged and archiving is not used, then the entire database must be restored using the most recent consistent backup. Now, to explain what backup means. A backup is a copy of data. This copy can include important parts of the database such as the control file and data files. A backup is a safeguard against unexpected data loss and application errors. If you lose the original data, then you can reconstruct it by using a backup. That ends my presentation. Thank you for watching.